Hello guys, welcome to Physics Unlocked. So I am here with very interesting problem of physics. So this problem was asked in JEE Advanced 2017. So in this problem, a uniform bar of length L AB is slipping from its vertical position on a frictionless floor. This is a frictionless floor at some instant of time. The angle made by the bar with the vertical is theta. So the at some instant the this bar makes theta angle with the vertical. So which of these following statements about its motion are correct? So we are given a uniform bar AB of length L, and initially it is standing vertically. So when it starts sliding, so at a certain instant it makes angle theta with the vertical. So if we make free body diagram of this uniform bar at any instant when it makes angle of theta with the vertical, so yeah, there will be a force, normal reaction force in the vertically upward direction exerted by this frictionless floor, and gravity will also act on this body from the center of mass and the vertically downward direction. So there are two forces acting on this uniform bar. First one is normal and second one is the gravity, which is acting from the center of mass in the vertically downward direction. So if we observe carefully, so there is no external force in the x direction. So there is no external force on this system in x direction. So sum of the forces in x direction is 0. Since there is no force in x direction, so the acceleration of center of mass in x direction will be also 0. So there will be no acceleration in the horizontal direction. That further implies that the velocity of the center of mass in x direction will be constant. So initially when it was in a vertical position, the velocity of center of mass in x direction was 0. So its velocity will remain constant and it will be always 0 in x direction. So there will be no velocity of midpoint, that is center of mass in x direction. So the center of mass will move in vertically downward direction. So as it starts sliding, the center of mass will gain velocity in vertically downward direction. It will always move in vertically downward direction. It will not have any component of velocity in x direction, that is horizontal direction. So option 1, the midpoint of bar will fall vertically downward. So it is absolutely correct option. So now coming to the option C. If we Option C is instantaneous torque about the point in contact with the floor is proportional to the sine theta. So the point in the contact with the floor is point B. So if we write the torques of the forces about this point, so the torque of the normal forces will be 0 since it is passing through the same point. So the torque of the gravity will be there. So if we write the torque of this weight, so it will be W L by 2 into sine theta. So this is the torque of the gravity about this point. So it is clear the torque is directly proportional to sine theta. So option C is also correct. Option C is also correct. Now let me solve option B and D on the next page. So our system somewhat looks like this. So at an instant theta, when it makes theta with the vertical, so if we write the coordinate of A, we have to find in this option B, we have to find the locus of A. So if we write the coordinates of point A, since the center of mass will fall vertically downward, so at this instant the center of mass will be some here. So this length will be L by 2 and this length will be also L by 2. So its x coordinate can be written as minus L by 2 sine theta and y coordinate can be written as L cos theta. So if we find sin theta and cos theta from these two equations, sin theta will be equal to this one and cos theta will be y by L. So if we square sin theta and cos theta and add both the equations, we will end up with this equation. So this is the equation of ellipse. So the locus of point A will be ellipse, not parabola. So the option B is wrong. So option B is wrong. Option B is wrong. Now coming to the option D. In this option, we are required to find the displacement of the midpoint. Displacement of the midpoint from the initial position. So we have to find the displacement of the midpoint. So when it was in the vertical position, the center of mass or the midpoint was at L by 2 distance from this floor. Now when it is making angle theta with the vertical, the center of mass of this system will be at the height of L by 2 cos theta. So its displacement can be written as final position minus initial position. In final position, when it is making theta with the vertical, the center of mass is at height of L by 2 cos theta and initially it was at the height of L by 2. So this is the displacement. Displacement will be minus L by 2 into 1 minus cos theta j cap. So this is the displacement of the center of mass. Since the displacement is proportional to 1 minus cos theta, so the displacement of the center of mass is proportional to 1 minus cos theta. So option D is also correct. Since it is given in this problem, it is proportional to 1 minus cos theta, so option D is also correct. So this is the required solution of this problem. Thank you.